I am not going to address the actual Roswell landing. What I am going to address is any alien life coming to Earth at all. Ever. I study astronomy as a hobby. I have ever since I was a kid. One of the questions anyone who studies astronomy will inevitably wonder is if alien life exists. It absolutely does / will, and if it has ever, or will ever, come to Earth. It has not, and will not. It's sad to be an astronomy lover and a sci-fi fan and know with such certainty that this has never occurred. So let me explain. 1. The size of the galaxy. This is not to be taken lightly or overlooked. The galaxy is absolutely enormous. I cannot stress that enough. Our galaxy is a barred spiral galaxy, and looks something like this. So how big is that? Well, in terms of distances, the Milky Way is 1,000 light-years thick, and has a diameter of 120,000 light-years. As per NASA, so let's imagine the Milky Way as a massive cylinder in space. What is its volume? Well, volume of a cylinder equals radius to height pi. That gives us approximately 10 trillion cubic light-years. That's a whole lot of space, and that's not including the massive amounts of dark matter in the Milky Way or the massive halo of stars that surrounds the Milky Way. So that is a hell of a lot of light-years. But what, exactly, is a light-year? In case you don't know what a light-year is, it is the distance that light travels in one full year, which is about 5.8 trillion miles, or 580,000,000,000,000 miles. The nearest star is 4.3 light-years away, meaning it is about 4.3 x 5.8 trillion miles away. NASA explains it quite well. So, again, let's go back to our imaginary cylinder that is the Milky Way galaxy. That sucker is 10 trillion cubic light-years of volume. And the light-year is 5.8 trillion miles. Therefore, every cubic light-year is 2.03 times 1038 cubic miles. This means that the volume of the galaxy is 2.03 times 1051 cubic miles, which looks like 200,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000 That is the volume of the cylinder that is our galaxy. Thanks to /u/Jack/u/Hozzy/u/YA, and everyone else who pointed out my earlier erroneous calculation, travel okay, you admit, the Milky Way galaxy is unfathomably huge. And, to top it off, it's only one of hundreds of billions of galaxies. But, as you correctly would point out, most of the volume we calculated previously is empty space, so you don't really need to search empty space for other life forms, you just need to look at stars and planets. Great point, but it gets you nowhere. Why? Well, even thought we've cut down our search to just the stars, we still have the astronomical problem of actually getting to them. Traveling from the Earth to the Moon takes about 1.2 seconds for light. You can see it in a neat little GIF right here. So how long did it take our astronauts in a rocket-fueled spaceship? It took the Apollo missions about 3 days and 4 hours to get there. So a trip that takes light about 1.2 seconds would take a rocket-propelled ship about 3.16 days, give or take. It takes light 8 minutes to get to the Sun. It takes light 4.3 years to get to the nearest star. Now just stop and imagine how long that trip to the nearest star would take going at the speed it took us to get to the moon. A dozen generations of human beings would live and die in that amount of time. The greatest technology we have and all of Earth's resources could not get these hypothetical astronauts even out of our solar system. And in doing so, the radiation would fry them like bacon, micrometeorites would turn them to Swiss cheese, and so on. So, our hypothetical aliens are not traveling on rockets. They simply can't be. The distances are enormous, the dangers unfathomable, and they don't have infinite time to be getting this mission done. Remember when I said that galaxy is 100,000 plus light-years across? Imagine traveling that in something that takes generations to go 4.3 light-years. There quite literally has not been enough time since the Big Bang for such a flight to be completed. So, clearly, anything making these journeys would need a method of travel that simply doesn't exist. We can posit anything from solar sails that accelerate a craft up to 99% the speed of light, or anything else that allows travelers to accelerate up to relativistic speeds in between star systems. The problem, however, is that acceleration/deceleration, as well as travel between these stars, maneuvering while in flight, and so forth, still takes years and years and years and years. And that's not including actually searching these star systems for any kind of life once you get there. You see, once you decelerate this craft within a star system, you still have to mosey your ass up to every single planet and poke around for life. You might think you could just look at each one, but it's not even possible for a telescope to be built that can see a house on Earth from the moon, so good luck finding life when you're on the other side of the solar system, and that's if the planet's even in view when your spaceship arrives. And how, exactly, are you going to poke around from planet to planet? What will you do to replenish the ship's resources? You certainly aren't going to be carrying water and food to last until the end of time, and without the infinite energy of the sun beating over your head, you're going to have a tough time replenishing and storing energy to be doing this mission even after you get as far as Saturn, where the sun becomes significantly smaller in the sky. So the logistics of getting from one star to the other are huge, unmanageable, a complete mess for propulsion systems of any kind. Everything Earth has could be poured into the mission and we wouldn't get out of the Oort cloud. And even if we did, then what? Cross your fingers and hope you can replenish supplies in the nearest star. How are you going to keep going after that? How suicidal is this mission? And that's just to the nearest star. What happens if the ship needs repairs? How many of these missions can you send out? If you only send out one, you're looking at taking eons just to search 1% of our galaxy, but the resources to send out a fleet of these ships doesn't exist. And how will you even know they succeeded? Any communication they send back will take half a decade to get here because those transmissions move at light speed. And that's if they manage to point their transmitter in the right direction so that we can even hear them. It would take us decades to even realize we need to send a second ship if the first one failed. Now remember how I said that the volume of the Milky Way wasn't relevant since you're just looking for stars and planets, not combing all of empty space? That wasn't 100% accurate, because now you're starting to realize that you actually have to traverse all of that empty space. To get from star to star requires crossing those unparalleled voids. That whatever the fucking however huge quadrillion billions of miles is suddenly looking a bit more massive again. And keep in mind, all of these deadly, insurmountable problems I've laid bare are just getting to the nearest star from Earth. And there are a lot of stars in the Milky Way, as we will shortly see. Added to include death, it's also worth noting that when traveling at relativistic speeds you are going to have an awful time maneuvering this ship. So what do you do when a rock the size of a fist is headed right for your vessel? You dive, that's what, because you are not getting out of its way. And that's if you see it, but you most likely would never know. Micrometers and space dust smaller than your pinky nail would shred your ship to absolute pieces. Space is not empty, it is full of small little things, and a ship with a propulsion system would slam into all of them on its journey. I cannot find the source, but a paper I read years ago proposed the smallest shield needed to safely do this on one trip would be miles thick of metal all around the ship, and that's only if the ship was as big as a house. Insanity. Propulsion systems will not work for this voyage if they're going that fast. The point being, so clearly, at this point, we have to resort to magic. That's right, no kidding magic. We're talking about faster than light travel, because anything else is utterly doomed. And honestly, there isn't much to say on FTL travel, because it's pure speculative magic. It's so crazy that in accomplishing it you create time travel, time paradoxes, and you break all of special relativity into nice tiny chaotic pieces. But, as this is hypothetical, I'm going to grant you faster than light travel. No explanation, we'll just use magic and be done with it, but if you're curious, here's some reading on the matter. Finally, we are going to keep all of this travel within the Milky Way galaxy. Why? Well, we're staying confined to just the Milky Way because, quite frankly, it's already an absurd scenario without magnifying all the problems by a magnitude of 100+ billion more galaxies. As stated earlier, there are hundreds of billions of galaxies. In fact, when Hubble looked out into a patch of sky smaller than your pinky nail, it saw 10,000 galaxies, but there are untold numbers of galaxies too far away to see, so that number is the minimum in just that patch of sky. There's a lot of galaxies in the universe. Stars and planets, okay, so I've granted you not only that we aren't searching all of the massive volume of the Milky Way, just the stars. I'm now granting you faster than light travel, with no explanation or justification, but that's how we have to play this game. But I still haven't even brought out the big guns, because the biggest and most important question of all hasn't been addressed. How many stars and planets are the aliens actually looking through, just in the Milky Way galaxy? Well, there are anywhere from 100 billion. 400 billion stars in just the Milky Way galaxy. Determining this number involves calculations of mass, volume, gravitational attraction, observation, and more. This is why there is such a disparity between the high and low estimates. We'll go with a number of 200 billion stars in the Milky Way for our purposes, simply because it's somewhat in between 100 billion and 400 billion but is still conservative in its estimation. So our hypothetical aliens have to only search 200 billion stars for life. Now we're saying the aliens have faster than light travel. Let's, in fact, say that the amount of time it takes them to travel from one star to the other is a piddly 1 day. So 1 day to travel from one star to the next. Yet, we still haven't addressed an important point. How many planets are they searching through? Well, it is unknown how many planets there are in the galaxy. This image shows about how far out humans have been able to find planets from Earth. Not very far, to say the least. The primary means of finding planets from Earth is by viewing the motions of a star and how it is perturbed by the gravity of its orbiting planets. We call these planets exoplanets. Now, what's really fascinating is that scientists have found exoplanets even around stars that should not have them, such as pulsars. So our aliens have their work cut out for them, because it looks like they more or less have to search every star for planets. And then search every planet for life. So, again, how many planets? Well, we have to be hypothetical, but let's assume an average of 4 to 5 planets per star. Some stars have none, some have lots, and so on. That is about 800 billion, 1 trillion planets that must be investigated. We gave our aliens 1 day to travel to a star. Let's give them 1 day per planet to get to that planet and do a thorough search for life. Now why can't the aliens just narrow this number down and not look at some planets and some stars? Because they, like us, can't know the nature of all life in the universe. They would have to look everywhere, and they would have to look closely. Summary. So we've given our aliens just under 1 week per solar system to accurately search for life in it, give or take, and that includes travel time. We've had to do this, remember, by essentially giving them magic powers, but why not? This is hypothetical. This would mean, just to search the Milky Way for life, by searching every star, and just to do it 1 time, would take them approximately 3 billion years, give or take. That is 1/5 the age of the universe. That is almost the age of the planet Earth itself. If the aliens had flown through our solar system before there was life, they wouldn't be back until the sun had turned into a red giant and engulfed our planet in flames. Anything short of millions of spaceships, with magical powers, magically searching planets in a matter of a day for life, would simply be doomed. Oh, but wait, maybe they can narrow it down by finding us with their radio transmissions, right? They're watching Hitler on their TVs so they know where to find us. Yeah, well, on viewing Earth and radio transmissions regardless of whether or not our magical aliens have magical faster than light travel. There is one thing that does not travel faster than light, and that thing is light. So how far out have the transmissions from Earth managed to get since we started broadcasting? About this far. So good luck, aliens, because you're going to need it. This is, of course, assuming the transmissions even get that far, because recent studies have shown that after a couple tiny light years those transmissions turn into noise and are indistinguishable from the background noise of the universe. In other words, they become a grain of sand on an infinite beach. No alien is going to find our TV/radio transmissions, possibly not even on the nearest star to Earth. So what if they have super-duper telescopes? Well, the size it would take for a telescope to view the flag on the moon just from Earth would need to be 650 feet in diameter. And that's if you knew exactly what you were looking for, and where, and were essentially on top of the thing. Seeing details of any planet like Earth from any distance outside the solar system is 100% impossible. Seeing details months inside the solar system would take massive telescopes, and even then you'd need to know where the planets are to look at, you'd need to know what you were looking for, and that's assuming the aliens you're looking for on those planets are just strolling around on the surface. After all, most of Earth is ocean and intelligent life could have easily evolved there and not on land. And what about underground? You need to study these worlds pretty carefully, though, granted, Earth has us just right up on the surface, making it easier once you are actually staring right at the planet. There is one final nail in this coffin, and that is one of time. Human beings have only existed on this planet for the past few tens of thousands of years. We've only had civilization for 10,000 years. In other words, if the entire history of the Earth were represented as a 24-hour clock, Humans have existed for a grand total of 1.92 seconds out of that 24-hour clock. The point is that this would mean an alien would not only need to find Earth within the entire unfathomable galaxy, they would need to find it within a specific time frame. It's not as though we'll be here for billions of years while they search, and if they are even a fraction too early, we won't exist yet. Think of it this way. If it only took the aliens 100 million years to comb the entire galaxy for life on Earth, they would have 0.001% of that amount of time as a window in which they could find humans at all. To find human civilization is 0.001% of that time. To find us as we are now is an even smaller fraction. In fact, the dinosaurs went extinct 60 million years ago, so even if they make a return trip, and if they were last here when the dinosaurs went extinct, they won't be due back for 40 million plus years. And that's if we give them ultra-super-duper magical powers so they can scan the whole galaxy in just 100 million years. So our aliens are not only finding our invisible planet in a crazy huge galaxy, they are finding it in a very specific and narrow amount of time. Outside of that, they'd be far more likely to find our planet as a frozen wasteland, a molten slag ball from pole to pole, or just find dinosaurs. Again, if they found it at all, ever, which doesn't seem terribly likely in the first place. Summary: so, as discussed, it is impossible for aliens to directly view Earth, the planet, and certainly not details of it from outside the solar system. It is impossible for them to pick up transmissions from Earth even at our nearest star. Therefore they have to actually go solar system to solar system in order to hunt down life, even intelligent life. The distances they must travel are enormous. The number of stars they have to search is enormous. The window they have to find us in is extremely small, so that even if they made a return trip it would be long after we are extinct. Combining these amounts of time needed, the amount of space to be searched, and the tiny fractional window they have to accomplish this in, we are looking at something that is an impossibility compounded by an impossibility. And that's not even getting into the fact that we're positing the aliens have existed for this long. How many alien intelligences are there in our galaxy? What if there's only one that ever pops up in any galaxy? What if there have been 1,000 others in the Milky Way but they're already all extinct? What if they don't exist yet? These are utterly unanswerable, which is why I don't go much into what the aliens are or how many there might be, but it does provide further layers upon layers upon layers of problems. The mess that one needs sift through to even begin to help for aliens bumbling into Earth and start probing us is enormous, unfathomable, immeasurable. So, I hope you can now see why Roswell is pure crap. It's a roundabout way of getting there, but I can say with absolute certainty two things. Given the massive size of the universe and the time it has existed, it is 100% certain that alien intelligence exists, or has existed, somewhere else in the universe. It is 100% guaranteed they have never, and will never, find us on this planet.